1969, a year that reshaped history. Woodstock electrified a generation, mankind walked on the moon, and somewhere on a forgotten drag strip in America, a guy named Jimmy launched his Chevy Chevelle so hard that the rear axle tore itself apart right at the starting line. That moment perfectly captured the raw spirit of the muscle car era: power, chaos, and the pursuit of mechanical perfection. But behind all that smoke and thunder were the unsung heroes of performance: the rear axles. The Ford 9-inch, the Dana 60, the GM 12-bolt, and Mopar's 8 3/4. Chunks of iron that decided who ruled the strip and who went home broken. They weren't just components. They were the bridge between 1,000-horsepower dreams and cold, hard pavement. While most manufacturers stuck to tried-and-true solid axles to handle those monstrous V8s, one company dared to do something no one else would. They tore up the rulebook entirely. What they built shouldn't have worked, but it changed everything. This is the story of the rear ends that defined an era. 4 iron legends and one revolutionary design that proved sometimes winning means playing a completely different game. It all started with the one that refused to die. Ford introduced its 9-inch rear axle back in 1957 for full-size sedans, never realizing it had accidentally built the most durable and adaptable rear end in automotive history. By the mid-1960s, hot rodders had discovered its secret, a design so clever it made gear swaps almost effortless. Instead of dismantling the entire housing, the Ford setup used a removable third member, a complete, self-contained differential assembly that could be swapped out in minutes. At the track, this meant one thing: total flexibility. If your gear ratio wasn't working, you didn't pack up and go home. You just pulled the center section, bolted in a new one, and you were ready to race again. Racers began carrying extra third members the way others carried spare tires, one for the street, one for the strip. Beyond its convenience, the 9-inch was built like it came out of a tank. The ring gear was enormous, the pinion support over-engineered, and the housing thick enough to weld reinforcements directly to it without cracking. Before long, this rear end started appearing under Chevys, Dodges, and even imports. Nobody cared about brand loyalty. They cared about not breaking parts. And decades later, the Ford 9-inch is still considered the gold standard. Even after Ford stopped using it in production cars in 1986, aftermarket manufacturers refused to let it die. Today, you can buy brand new housings, gears, and third members that are stronger than anything Ford ever made. More than 60 years later, this rear end still defines what reliability means in high-performance builds. But behind all that smoke and thunder were the unsung heroes of performance. When Chrysler needed something that could survive the savage torque of a 426 Hemi or a 446 pack, they didn't play around. They went straight to Dana Corporation, the same company building axles for heavy trucks and industrial machinery, and told them to make something that could take unlimited abuse. The result was the Dana 60, a masterpiece of raw strength. Its massive 9 3/4-inch ring gear, thick axle shafts, and cast iron housing made it nearly indestructible. It wasn't just tough, it was legendary. Street racers discovered they could hammer these cars with nitrous, dump the clutch on slicks, and the axle would laugh it off. Engines blew up, transmissions exploded, but the Dana 60 never quit. NASCAR teams caught on fast, adapting versions of it for high-speed endurance races where reliability meant survival. It was heavy, no doubt about that, but in big-bodied Mopars like the Charger, Roadrunner, and Challenger, that extra weight planted the tires and gave them unbeatable traction. In smaller A-body cars like the Duster or Dart, tuners learned to work around it, turning the extra mass into an advantage during launches. Even today, when a car builder says they're making serious power, chances are there's a Dana 60 sitting under the rear end, because when failure isn't an option, there's simply nothing better. General Motors, on the other hand, took a more balanced approach. Instead of building something monstrous or unbreakable, GM wanted a rear end that was strong enough to handle serious power, but still light and efficient. The result was the 12-bolt axle, introduced in 1965, and it quickly became a favorite among muscle car builders. Its 8 8/7-inch ring gear and 12-bolt carrier provided just the right mix of strength and weight. You'd find it behind the most iconic GM cars of the era: Chevelles packing 454 big blocks, Camaros with high-speed small blocks, and GTOs with ram air engines built for all-out performance. What made the 12-bolt special was how versatile it was. You could thrash it at the drag strip on Saturday, then drive to work on Monday with no issues. It could handle 600 horsepower if built right, and because GM used it in so many cars and trucks, parts were everywhere. Junkyards were full of them. Builders could grab one, clean it up, throw in stronger gears, and go racing. It wasn't the strongest axle ever made, but it didn't need to be. It was the perfect middle ground, strong, reliable, and easy to find. That balance made it the working man's favorite. While the Ford 9-inch and Dana 60 were expensive or rare, the GM 12-bolt was accessible. It was the axle that proved you didn't need unlimited money to build a car that could win. It was strength and smarts rolled into one, and for many racers, it hit the sweet spot between performance and practicality.
Cars equipped with the GM 12-bolt rear end were always in the fight, no matter who lined up beside them. It wasn't the strongest axle ever built, and it didn't need to be. What made it legendary was its perfect balance. Strong enough for racing, light enough for the street, and easy to find when something broke. Even today, if you're restoring or building a classic muscle car that's going to see both daily driving and drag strip duty, this setup still sits near the top of the list. It's not exotic, not overbuilt, but it just works. It's the kind of engineering that doesn't shout. It quietly delivers, year after year. But now comes the real game changer. The rear end that flipped the entire conversation and proved that sometimes progress doesn't come from adding more strength, but from rethinking the problem entirely. The Mopar 8 3/4, the underdog that earned a cult following among those who actually understood how things worked. While other automakers were chasing heavier and more complicated designs, Chrysler's engineers took a different path. They asked themselves a simple question. What if we combined the smartest features from everyone else into something lighter, simpler, and more efficient? Their answer was brilliant. Borrowing the removable third member concept from Ford's 9-inch, Chrysler designed a system that let you change gear ratios in your own garage without tearing apart the entire rear assembly. But they refined it. Instead of building a bulky, over-engineered monster, they made it compact and practical. For Dodge and Plymouth owners, this meant flexibility. You could run highway-friendly gears during the week, then swap in a drag setup on the weekend, all without losing your mind or spending a fortune. What would take days on other cars was now a Saturday afternoon project with a wrench and some patience. Yet the real genius wasn't just convenience, it was geometry. Everything about this design, from the angle of the pinion to the placement of the ring gear, worked in harmony under stress. When most rear ends flexed or fought themselves during hard launches, the Mopar 8 3/4 seemed to get stronger the more you pushed it. Its precision under load was what made it a street racer's secret weapon. You'd see guys running small block darts or road runners that looked mild from the outside, but underneath sat that perfectly tuned 8 3/4 that could take abuse all night long. There's an old story from the track that sums it up perfectly. A local racer, everyone called him Tony, drove a modest-looking Dodge Dart with a warmed-up 340 and one of these rear ends. Friday nights, the heavy hitters would line up against him, confident their massive axles gave them the edge. Tony would just smile and say, "Let's see what happens." And more often than not, he'd leave them behind. It wasn't because his setup was stronger on paper, it was because it was smarter in practice. The Mopar design didn't fight the forces inside it, it used them. Eventually, the aftermarket caught on. Companies began making upgraded housings and heavy-duty internals, but the core idea stayed untouched. Because when something works this well, you don't need to reinvent it, you just make it stronger. Even now, serious Mopar builders swear by the 8 3/4, not just out of nostalgia, but because it delivers. Simple, effective, and brilliantly engineered. And yet, as revolutionary as that was, the real shockwave came from somewhere no one expected. While every American muscle car was still relying on solid rear axles, Chevrolet did something that looked, at first, completely insane. In 1963, they gave the Corvette an independent rear suspension. It wasn't a tweak or an upgrade, it was a total reinvention of how a car puts power to the ground. The kind of decision that could have gotten an engineer fired, but instead changed the future of performance. Every automaker laughed at first. Solid axles were proven, simple, and strong, perfect for straight-line racing. But Chevy's engineers weren't thinking about the drag strip. They were studying European sports cars, machines that cornered like they were on rails. They realized that if each wheel could move independently, the car could stay planted on uneven pavement, keeping power down through corners instead of losing traction. That idea became the heart of the 1963 Corvette Stingray, a car decades ahead of its time. Drag racers didn't get it. To them, the setup was complicated, expensive, and too delicate for hard launches. But road racers and performance enthusiasts saw something incredible. The Corvette wasn't just fast, it was agile. It could blast through corners with precision that left traditional muscle cars struggling for grip. For the first time, American performance wasn't defined by brute force alone, but by control and balance. The independent suspension was also lighter than most solid axles, reducing unsprung weight, the part of the car that moves with the tires. That meant quicker acceleration, better braking, and sharper handling. On paper, it was radical. On the road, it was transformative. Chevy had quietly proven that muscle could be intelligent, that precision could be just as powerful as raw strength. The rest of the industry took years to catch up. By the 1970s, other manufacturers started experimenting with independent rear setups. By the 1980s, it became common in performance cars. And by the 1990s, it was standard across nearly every sports car on the planet. All because in 1963, one company dared to ask, what if we stopped building stronger axles and started building smarter ones? In the end, every one of these legendary rear ends answered the same question in a different way. How do you turn engine power into motion without losing it all in the middle? The Ford 9-inch said, make it tough enough to survive anything. The Dana 60 said, build it so strong that failure isn't even an option. The GM 12-bolt said, find the perfect balance. The Mopar 8 3/4 said, work with the forces instead of fighting them. And the Corvette's independent setup asked the boldest question of them all. What if we've been thinking about it wrong all the time? They weren't just metal housings or gear sets. They were symbols of an era when engineers didn't play it safe. They experimented, risked failure, and changed the rules of performance forever. Every burnout, every race, every victory that defined American muscle owes something to these mechanical masterpieces. Because horsepower means nothing if you can't get it to the pavement. And these were the machines that made sure every ounce of power found its way there.